Good afternoon. Today in math, we're going to continue talking about whether numbers are prime or composite, but today we're going to learn how to determine whether really big numbers are prime or composite. So we already know how to determine whether a smaller number is prime or composite. So let's look at an example. If we have the number 36, I know my multiplication table, so I know that to make 36, we can do 1 times 36, we can do 2 times 18, we can do 3 times 12, we can do 4 times 9, and we can do 6 times 6. There's a lot of different ways to make 36. It has a bunch of different factors. So because it has more than 2 factors, it in fact has 1, 2, 3, 4, 5, 6, 7, 8, 9, because that's the same one. It has 9 factors. So it has more than 2 factors, so that makes the number 36 composite. I figured that out just because I knew my multiplication tables. Let's do another one. This time we're going to do the number 14. I know that you can make 14 by doing 1 times 14 and 2 times 7. It has 1, 2, 3, 4 factors. It has more than 2 factors, so this one is also composite. Let's try the number 13. When I think about my multiplication tables, all I can think of is 1 times 13. Since it only has 2 factors, 1 and itself, this number 13 is prime. Now these numbers are easy, 36, 14, 13, because they're small numbers and I know my multiplication tables for those numbers. The problem becomes when we get larger numbers, like let's say this number that we're not so sure about, like let's say 242. That's a big number. I do not know my multiplication tables all the way up to 242. So today we're going to talk about some tricks that we can use to figure out whether a number is prime or composite when it's big and we don't know all of our multiplication tables. So you're going to need to take out your notes, the page on divisibility. Okay. Now this first page tells you that divisible means capable of being divided. So if a number is divisible by another number, that means you can divide it by the other number. And a number is divisible by all of its factors. So let's take a number that is easy for us to discuss divisibility, like 20. 20 is divisible by all of its factors. So we can make a factor tree. We can do not a factor tree, a t-chart. 1 times 20, 2 times 10, 4 times 5 makes 20. So it has 1, 2, 3, 4, 5, 6 factors. 20 is divisible by 1. 20 is divisible by 20. 20 is divisible by 2. 20 is divisible by 10. 20 is divisible by 4. And 20 is divisible by 5. That means that if you divide 20 by any of these numbers, so like 20 divided by 5, 5 goes into 24 times, you get a whole number. So 20 is divisible by all of these different numbers. Now let's look at these two categories and check out one of these is prime and one of these is composite. This is a number that has just 2 factors, 1 in itself. It is not divisible by any numbers except for 1 in itself. You can only divide it evenly by 1 in itself. And its only factors are 1 in itself. Sorry, that matches the first one. Okay. Pause your video, write for me what kind of number that is, and then come back and find out. I hope that you wrote that this is a prime number. Now the other kind of number has more than 2 factors. And again, this last one is the same, I apologize. More factors than just 1 in itself. Like this number 20 up here has a lot of different factors. And it is divisible by a number or numbers other than 1 in itself, just like 20 is divisible by all these different numbers. Pause the video and tell me what kind of number that is. I hope that you wrote composite. Now we can use divisibility to help us figure out whether a number is prime or composite. Because if a number is divisible by a different number, That means that it cannot be prime. If a number is divisible by any number other than 1 or itself, it has to be a composite number. So we can actually use some tricks to figure out if a number is divisible by different numbers. We're going to use our second page here. So if a number is divisible by 2 if it is an even number. Any even number is divisible by 2. So pause the video, write an example of an even number. I'm going to write one up here, and then you can come back. I have a couple different ones. The number 242, that number we talked about before, it ends in a 2, so it is an even number, which means it's divisible by 2. 9,678, that ends in an 8. It's an even number, so it is also divisible by 2. Any number that is an even number and is divisible by 2 is a composite number. Oh, sorry, I forgot. Because the last digit is even. That is why these are divisible by 2. So if it's an even number, it's not prime, with the exception of our special number 2, which we talked about in the other video. Now, there's also a trick to figure out if a number is divisible by 3. If the sum of all the digits is a multiple of 3, that means if you add up all the digits. So example for this number, 242, 2 plus 4 plus 2. 2 plus 4 is 6, plus 2 more is 8. 8 is not a multiple of 3 because the multiples of 3 are skip counting, like 3, 6, 9, 12, 15. So 242 is not divisible by 3 because when you add them up, it doesn't equal a multiple of 3. This number 51 is, because 5 plus 1 equals 6, and 6 is a multiple of 3. What about this number? 921. 9 plus 2 plus 1 is 12. And 12 is a multiple of 3. So this number is divisible by 3. If you did it on a calculator, 921 divided by 3, it would work. So those work because, oh, I should have put these over here. This work that I showed, because the sum of the digits is divisible by 3, belongs in that box there. The last trick you can use is the divisibility of 5 rule. If the number ends in a 0 or a 5, it's divisible by 5, because if you skip count 5, 10, 15, 20, 25, 30, 35, 40, keep going, all those numbers end in a 0 or a 5. 100 ends in a 0. 3,725 ends in a 5. It ends in 0 or 5. So we're going to check some of these larger numbers down here and use these 3 rules to figure out if the number is prime or composite. So here's our first number, 234. Do we know any multiplication facts that help us with 234? I sure don't. So I'm going to leave that one blank. Is this number divisible by 2? Remember, our rule for divisibility by 2 is it an even number? It ends in a 4. Yes, this number is divisible by 2 because it's even. Now, I already know now that it must be composite, but I'm going to keep going. Is it divisible by 3? The rule is to add up all the digits. So 2 plus 3 plus 4. 2, 3, 4, 5 plus 4 more. 6, 7, 8, 9. Ooh. So that number 9 is a multiple of 3. It is divisible by 3. Okay? Is it divisible by 5? Does it end in a 0 or a 5? No. But because it's divisible by 2 and it's divisible by 3, it has to be composite, because that means 2 and 3 are factors of this number. And a prime number only has 2 factors, 1 and itself. So let's look at this next one, 51. Do I know any multiplication facts for 51? I don't, so I'm not going to check that one. Is it divisible by 2? Is it an even number? No, it ends in 1. It is an odd number. Okay. Is it divisible by 3? Let's add up the digits. 5 plus 1 equals 6. Oh, yes, 6 is a multiple of 3, so it is divisible by 3. That means it's composite because 3 is a factor of 51. And we can check again, it is not divisible by 5 because it doesn't end in 0 or 5. Let's do 97. Do I need to do a multiplication fact for 97? I don't, it's too big. Is it divisible by 2? Let's check. It is not an even number, so it is not divisible by 2. Is it divisible by 3? Let's add it together. 9 plus 7. So 9 plus 7 is 16. 16 is not a multiple of 3, so it is not divisible by 3. Is it divisible by 5? Does it end in 0 or 5? No. So we're going to guess that this number is probably prime because I can't find any factors. What I'm going to ask you to do is these last two by yourself. See if you know a multiplication fact. See if it's an even number, so it's divisible by 2. Add the digits and see if it's a multiple of 3. See if it ends in a 0 or a 5. And then tell me if you think the number is prime or composite. We're going to continue using these divisibility rules to help us with big numbers tomorrow in class. Best of luck. You can do it.